This question shows a thermistor in a potential divider circuit. And from the graph, you can see that as it becomes hotter and hotter, the voltmeter reading increases. And in a while, in part A, you have to explain why is this the case. So when it becomes hotter, the resistance of this thermistor over here will actually decrease. And when the resistance of the thermistor decrease, from the potential divider concept, it will grab a smaller share of the 6 volts. The voltage across this thermistor will decrease. Therefore, the voltage across the fixed resistor will increase. In part B, you are to determine the resistance of the thermistor when the temperature is 40 degrees Celsius. So the first step we do is to read off the graph. At 40 degrees Celsius, we can see that the voltmeter reading is 3.6 volts. So we know the voltage of this resistor to be 3.6 volts. We know the resistance of this resistor to be 1600 ohm. We can then use Ohm's law to figure out what is the current passing through this circuit. And that is the first step that we will do using Ohm's law. And we can get this current value. Now, we will then look at the thermistor. The voltage across the whole circuit is 6 volts. The voltage across the fixed resistor is 3.6 volts. So the sum of these two voltages should get you 6 volts, and then we can use this relationship to figure out the voltage of the thermistor to be 2.4 volts. With that, applying Ohm's law on the thermistor with a voltage of 2.4 volts and a current of 0.00225 amperes found previously allows us to determine the resistance of the thermistor. Now in part B, there's also an alternative method. We can use a potential divider method, and it's in fact a faster method. So the same thing, we will read off the graph at 40 degrees Celsius what is the voltage reading of the resistor, and it's 3.6 volts. And let's write out the potential divider equation and plug in the known resistance of 1600 ohm into the equation. We know that the voltage reading is 3.6 volts, so let's plug 3.6 volts into the left hand side. The EMF of the whole circuit is 6 volts, so 6 goes here. And you have one equation, one unknown. Therefore, solving the equation gets you the same answer of the thermistor resistance to be 1100 ohm. In part C, we are to overlay the voltage across temperature graph of the thermistor. And the given graph to us is the voltage against temperature graph of the resistor. So the concept here is actually pretty simple. You have to recognize that the voltage of the thermistor plus the voltage of the resistor add together, that will be 6 volts, because these two items are connected side by side in series. So I will first look at the first point. If you look at this point over here, this coordinate over here, the voltage of the thermistor is 0.9 volts at this point. 0.9 volts plus 5.1 volts gets you a total of 6 volts. Alright, so this is how we can get the voltage of the thermistor. And the voltage of the thermistor plus the voltage of the resistor add together must give us 6. Let's try again for one more coordinate. If you look at over here at 20 degrees Celsius, the voltage of the resistor is roughly 2.2 volts over here. So 2.2 volts voltage plus something must give me 6 volts. So therefore the balance is 3.8 volts voltage of the thermistor plus 2.2 volts which is the voltage of the resistor, add together will give me 6 volts. So we can just continue choosing coordinates from the original graph of the resistor, and then plot out the corresponding voltage of the thermistor like this. Just bear in mind the same strategy, that the two voltages add together must give you 6 volts, and just draw a smooth curve through it. In part D, you are to determine the temperature of the thermistor when the current through it is 2.5 milliamperes. So we note that the current passing through the thermistor is also the current passing through the resistor, because these two components are connected in series side by side with each other. So we can now look at just the resistor. We know the current passing through it to be 2.5 milliamperes. We know the resistance to be 1600 ohm. Therefore, Ohm's law can be applied, and we can find the voltage across the resistor to be 4 volts. Once we get this value, we can simply just read off the graph. For the voltmeter reading of 4 volts, the temperature of the thermistor is 48 degrees Celsius.